Hey everyone, in today's video let's cover the next part of functions. We are going to deal with the types of functions: injection, bijection and subjection. Let's begin. Firstly, we have the injection or 1-1 function. It is either known as injective function or a 1-1 function. Alright. In such a function, different elements have distinct images. Now what are images for this? Let me make you understand. Let's say this is set A and set B. Here I have some sort of mapping in this manner. Now if you look at this, 1, 2, 3, 4, they are known as pre-images. And whatever the elements are there in set B, they are known as images. That means A, B, C, D are known as images. 1, 2, 3, 4 are known as pre-images. Alright, this is the basic thing that you have to know. Now what does this 1-1 function say us? It says us that different elements have distinct images. What does this mean? Let me put on a layman definition. No two elements in the first set have the same image in the second set. Now it means that no two elements can have the same image. That means here I have 1 and 2. The 1 and 2 cannot be mapped with A only. This is not a 1-1 function. That means the elements in A should have a unique mapping with the elements in B in this manner. Let's say like this. 1 is mapped with B. It is not mapped with any other image in B, right? Such a function is known as a 1-1 function. Now what if I say I have a mapping in this manner? Is this a 1-1 function, everyone? This is not a 1-1 function. Why? Because two elements in A are mapped with only one element, only one common element in B. So this is not a 1-1 function. Now, one of my friends asked me, if it is not 1-1, then what is that type of function known as? Well, if it is not a 1-1 function, it is known as a many-one function. Alright, so such the function is known as the many-one function. Let's see a few more examples. Now have a look at these two examples over here. Here if you observe, 1 and 2 are mapped with C. Is this a 1-1 function? No, it is not a 1-1 function. That means it is a many-one function. On the other hand, we have the second example where 7 and 2 are mapped with only one element in B, that is D, right? And this as well is not a 1-1 function. It is a many-one function. Now, let's convert this many-one function into a 1-1 function in this manner. Is this now a 1-1 function? Yes, it is a 1-1 function. That means different elements have distinct images. That's what it means. Moving forward, we have the subjective function or an onto function. Here it means each element of B is some image of the element in A. Now it means here I have set A and B, 1, 2, 3, 4, A, B, C, D. Now, here if I need to have a layman's definition, it means that every element in B should be busy with some element in A. That means every element in B should be aligned or mapped with any element in A. That is what it means. Okay, here let's say I have mapping in this manner. And I'm having, one second, let's suppose say I have E as well over here. Let's say this is E. Now let's map them. Now, is this a subjective function or an onto function? No, it is not, because one element in B is still left over and it is not mapped with any element in A. So, it is not an onto function. Now, one of my friend asked me, if it's not onto, then what is it called? It is known as into function. If it is not subjective function, it is into function. Okay. Now in order to make it a subjective function, here I display my 5 where I'm going to map it with E. Every element in B is the image of some element in A, isn't it? Now let's suppose say I remove this mapping and say my mapping is in this manner. Is this a subjective function? Definitely yes, because every element in B is busy with some element in A. It is aligned with some element in A, and that is why we call it as subjective function or an onto function. And the function which is not an onto function is known as a into function. Here, one thing that you're going to keep in mind while we are talking about onto function is the codomain will always be equal to range in an onto function. Codomain is equal to range, isn't it? Here in this example, what is the codomain? A, B, C, D, E. What is the range? Range are the number of elements which are mapped, right? So A, B, C, D, E again. Aren't they equal? Yes. So codomain is equal to range in a subjective function or an onto function. Moving forward to the last function that we have is a bijective function or a bijection. Now here, this type of function, here if you look at these two definitions, they are known to us previously. That means here bijection means it is a combination of both 1, 1 and onto function. If both are there in any function, they are known as a bijective functions. Alright, that means no element in first set have the, no two elements in the first set have the same image in the second set. Each element of B is the image of some element in A. If these two conditions are satisfied in any example of a function, then it means it is a bijective function. Here I put on one example for all of us. Here, let's say 1, 2, 3, A, B, C. Firstly, the first condition says that different elements have distinct images. Now I put it in this manner. And if you observe, the second condition is satisfied as well. That is, each element in B is mapped with some element in A. So this is a bijective function, which is both a combination of onto function and 1, 1 function. So bijection is a combination of injection and subjection. Well, that dives us to the end of this video, but do not forget to like, share and subscribe. Thank you.